In Chapter 8, as you know, we've been working with rational functions. Mainly, we've just been graphing them. But in these next two chapters, we're going to look at how you multiply and divide, and then add and subtract them. So since you know rational functions, we've been dealing with fractions. We're just going to do some quick fraction practice, because I know it's been a while. So we're going to focus on simplifying in the first one, multiplying, and then dividing. So in the first one, all I'm trying to do is reduce 15 over 65. So you have to ask yourself what common factors they have, and we can recognize that 5 goes into 15. We know 5 goes into 15 3 times, and 5 goes into 65 13 times. So it's just reduced. When we're multiplying fractions in the second example, all we do is multiply the top times the top and the bottom times the bottom. So we've got 32 over 45. Now dividing, we have to remember that dividing fractions is the same as multiplying by the reciprocal. So this is the same thing as 3/5 times 7/12. Then it's just the same property as before. So 21 over 60. Reduce that, 3 goes into 21 and 60. 7 over 20 is your reduced fraction. So we're going to be doing these properties, reducing, multiplying, dividing, where we multiply by the reciprocal, but we're going to have quadratic functions involved and expressions that we have to factor and then simplify. So this is your Chapter 8-4, looking at multiplying and dividing. All right, so when we simplify rational expressions, you need to think that when you're doing this, there needs to be no common factors in the numerator and the denominator. So we say that a rational expression is in simplified form if there are no common factors in the numerator and denominator. Now you're going to have to do the factoring in most cases, but in these first, at least in this first example we're going to do, it's going to be factored for you. So we just have to recognize what's the same in the numerator and the denominator, and if it is the same, we're just going to cancel it out to simplify it. So this whole time when we're simplifying, you're thinking, can I factor these expressions? And if I can, then are there factors that are the same in the numerator and denominator that I can cancel out? So here's a rational expression. Looks like a fraction, right? We've got an expression in the top and in the bottom. So to simplify it, I need to look for things in common. So as you can see, there's an x plus 3 in the numerator and the denominator. We know that if we divide something by itself, it's just 1. So that's why I can just cancel those out, because they're equivalent to 1. So then I'm just left with 4 over x minus 5. And that's your simplified form. Now in the second one, notice I've got two quadratics, and they're not factored. So before I can go about simplifying this, I have to factor them. So we recognize that in the numerator, the leading coefficient's 1, so I don't have to do the AC method. I'm just looking for factors of 16 that add to -8, and that would be -4 and -4. So factor the numerator. Same in the denominator. Leading coefficient's 1, so what are factors of -24 that add to 2, 6, and -4? Now that they're factored, we recognize there's an x minus 4 in the numerator and denominator. X minus 4 divided by x minus 4 is just 1, so I can just cancel them out. And the simplified form is x minus 4 over x plus 3. The last one I wanted to throw out because we're not factoring using this method, but we're just looking for a greatest common factor because we've got two terms. So in the numerator, notice that they both have an x in common, so I can factor out an x there. I'm left with x plus 7. And in the denominator, I just have, you can write it as x times x if you'd like. that might help you see that these x's are going to cancel. So we're just left with x plus 7 over x. You could have, from the beginning, recognized that all of these have an x in common and reduced it that way if you didn't want to factor it. But what you cannot do is cancel out the x squareds. Because you're adding here, I can only cancel when I'm multiplying like in this case. All right, so I just wrote out some kind of quick steps for you to recognize. If you look in the book, it kind of has these same written for you. You're always going to factor the numerator and denominator, divide out common factors, write it in simplified form. Now, in these cases, we're multiplying. In the last 3 examples, all I was doing was simplifying. So notice here I have a rational expression multiplied by a rational expression. In this first case, there's nothing to factor. They don't have anything in common. I can't factor 8x cubed y. Nothing to do there, or in any of the numerators and denominators. So I'm just going to start out on this one by just multiplying the fractions, which means I multiply the top times the top and the bottom times bottom. So I've got 8 times 7. I'm just going to multiply my like terms. X cubed times x to the 4th. Remember, we're multiplying and bases are the same, so we add the exponents. And then I've got y times y cubed is y to the 4th. Multiply the denominator, 2 times 4. X doesn't have anything in common. And then y squared times y is y cubed. So once I've made it one fraction, now I can just go through and divide out anything that's the same. So 56 divided by 8 is 7. X to the 7th divided by x, remember we subtract the exponents, so 7 minus 1 is 6. And 4 minus 3 is 1. So this is your simplified form. Now on the second one, here I can factor. So that's how I'm going to start on this one. The only reason I didn't up here was because I couldn't factor any of these. Here though, I can factor this numerator and this denominator, and even this one if I want to. So if I'm looking at the first numerator, it's got 2 terms, so be on the lookout for a greatest common factor. 2x squared and negative 10x have a 2x in common. And then I'm left with x minus 5. X squared minus 25, that should look familiar to you. It's a difference of squares pattern. So that's going to factor into x plus 5, x minus 5. We'll just leave these as being multiplied for a second. Can't do anything with x plus 3. And then if you want to, you can write 2x squared as 2 times x times x. Sometimes writing it out like that just helps you see what can be canceled out a little bit easier. So now before we multiply, let's divide out any common factors that we see. So I see x minus 5 in the numerator and denominator. That's just 1. I see a 2 in the numerator and denominator and an x. It doesn't matter that they're on different fractions because they're going to be multiplied into one fraction anyway. So as long as one's in the numerator and one's in the denominator, I can cancel them out. Nothing else is in common. So my simplified form is going to be x plus 3 over, I've got this x right here, times this expression, x plus 5. Now I want it simplified, so I'm not going to distribute the x back through. Okay, I'm going to leave it in its factored form. All right, let's look at one more multiplying one before we do division. Notice every numerator and every denominator can be factored here. So we're going to have to factor 4 different expressions. So in the first one, factors of negative 4 that add to 3, it's 4 and negative 1. Factors of 4 that add to 4 are 2 and 2. (2x squared plus 4x, look for a greatest common factor, and they have a 2x in common. Factors of 3 that add to negative 4 are negative 3 and negative 1. So before I multiply, let's go through and divide out everything that's common in the numerator and denominator. X minus 1, x plus 2, and that is it. So let's multiply top times top, bottom times bottom. So I've got 2x times x plus 4 in the numerator, and x plus 2, x minus 3 in the denominator. Again, don't multiply them through because I want it in the simplified form, and that's the factored form. So that's your final answer. All right, last one's dividing. There's one added step here, but other than that, we're going to do everything the same. The first thing we're going to do is rewrite by multiplying by the reciprocal, just like we did in the first few fraction practice problems. When you're dividing fractions, that's the same as multiplying by the reciprocal. So we're going to do that. Then we're going to factor, divide out, and write in the simplified form. So once you rewrite it, these last 3 steps are the exact same. So divide and simplify. Very first thing I'm going to do is rewrite it as multiplying by the reciprocal. Now it looks like the last 3 problems we just did. We're going to go through and factor. Can't do anything with 4x. 5x minus 20, greatest common factor of 5 there. Take out a 5, I'm left with x minus 4. Factors of 8 that add to negative 6 are negative 4 and negative 2. X squared minus 2x have an x in common. And go through and cancel out what you can. X minus 4, numerator and denominator. X minus 2, x. Everything cancels out except for the 4/5. This last one I wanted to throw out there because the second one doesn't have anything in the numerator. So don't let that confuse you. If you want to just write it over 1 so it looks like a fraction, do that if that helps you. So again, start by rewriting it as multiplying by the reciprocal. So never change your first fraction, but the second one is the reciprocal. Now, if you look at the first numerator, it's got a leading coefficient of 2. So I cannot do the quick way of factoring that I've been doing. I have to do AC method. So I'm going to just do my work down here at the bottom. A times C, 2 times negative 5 is negative 10. So factors of negative 10 that add to 3 are 5 and negative 2. So remember, we split the middle term into those 2 numbers. So I split 3x into 5x minus 2x because that's the same thing. Now we draw our line down the middle and we pull out the greatest common factors. 2x squared plus 5x has an x in common. We're left with 2x plus 5. Negative 2x minus 5 has a negative 1 in common. And we're left with 2x plus 5. Remember, you want the leftovers to be the same. So my 2 factors are x minus 1, that's what I pulled out, and the leftover 2x plus 5. So you will have to do AC method once in a while with these problems. So this numerator factored into x minus 1, 2x plus 5. 6x, can't do anything there. Can't do anything with 1. 2x squared plus 5x has an x in common. So not much is going to cancel here except for the 2x plus 5s. Then go ahead and multiply the numerator. The denominator, 6x times x, you can write that as 6x squared if you'd like.